starting to feel a bit dizzy, but I will continue to explain that. So it's already 3 a.m. I'm here today to talk about some tool that I'm starting to fall in love with, and just helps you to monitor, let's say, to help you monitor your resources on the machine that you're working on. Okay, to have a bit of context, let's go back here, and as you can see, this is a Dockerized environment, containerized environment, Dockerized environment. They are the same thing, where I run a Jupyter server, where I have a Python script that actually fine-tune an LLM on a specific task. I think it's geospatial dataset, about like making the model specialized in geospatial, or geoscience in general. Sorry, I'm not really good at LLMs and how like to instruct LLMs. Deep learning is not my thing, not yet. And like I get this script with the help of ChatGPT. So I'm running the script and I provide the parameters, and we should like fine tune that model. But I had problem, and most of the time this problem is COO, or like CUDA out of memory. And CUDA out of memory is just um, it's a fancy word of saying that your RAM is used and there is no space left in your memory, your GPU, of course, since like we are talking about CUDA here. So yeah, as you can see, like let me SSH to my machine. So okay, I have this node, and if you want to see like my specifications, you can see that I have two Tesla B100, 60 gigabits of RAM. So I have a node with two GPUs, and okay, and as you can see that it's like B100. B100 is like a very old architecture. It's not the most recent, but at least there's a reason why I picked it, because it's just compatible with the stack that I have now, with all the tools and the software dependencies I'm using for this experiment. And I'm not really like ready to dive into something that I'm not sure if it will break or it will stand. So like I'm somehow sure about this kind of GPU. So I have two of them, and I may underestimated how computational expensive it is to train, um, like fine tune an LLM. So at first, I've tried to, let's say, have these working arounds on, yeah, lowering the precision as an example. So if I'm using like the default 32 bits, I'm going to use a bit precision of 16 or 8. And also workarounds about the batch size and whatever. There are like multiple workarounds you can do to make the memory footprint much more, let's say, affordable to the GPU. So it is not always full of memory. But there is actually a problem that even though I've used a smaller model version, I'm not really a scientist on calculating, on having the intuition on like, does this model actually can run on B100 or not? And I have two of them. So I kind of suspected that it might not worked on one of the, or it might only picked one of the GPUs, because I never paid attention to what was like the torsion scaler and what was the CUDA device selected. And indeed, like I've looked up and I've seen that it was using only one of the two. So the tool is called nvtop, and it's very awesome. It provides you with this. It's literally a GUI inside CLI. Like, it's for real a GUI, and this is what's cool about it. And I think like it comes from the top library itself. Maybe it's built on top of it. So there's this, I think top comes default in Linux, and it gives you the command which is like the process that's already happening now, and then how much CPU and memory they are using, and then a bunch of other information about that process. And it's basic, it doesn't provide GPU information, and yeah, it doesn't give or help in monitoring GPUs. But there is this amazing tool called nvtop, which I suspect, and I'm not sure, it's built on top of top because like it starts with nv. I might search about this later, but now it's on my device and I'm installing it. We can see that it gives you how many devices you have. So I have device 0 and device 1, and the error that I had earlier, there was only depending on GPU 1. So all the workload is supposed to be done by one device, which is sometimes if it couldn't handle it, it should refer or distribute to the device 1. So far I'm like, I feel like I'm in this dashboard room where I can monitor how the process is happening, which is cool and which is awesome. So if you have code out of memory, you might try to look up for such a tool, and you might try also to see how the workload is being distributed. As you can see, the distribution of the workload in my current situation is not actually one to one. It's not very well balanced, so it's not distributed in a good manner. I'm not sure why, but I might try to work on that so you can see how your resources are being dedicated with this just an amazing tool, and I really love it. I think there was like a similar tool where I wanted to see how the network is actually dedicated for some of the tasks, and I've ended up using this tool. Okay, it's not installed. I think I need to do sudo apt update, and let's like try to quickly install this. It helped me a lot understanding how the objects and all the artifacts are being sent over the network to my S3 remote buckets. And I was just playing with configurations. They are like fast flags I need to set, and I needed to see how is the caching mode will changes my transfer speed over the network. And I needed to find some tool that will help me monitor the network. And this, I think, if I said sudo apt install nload, it should. Okay, I think we have installed. So this one really helps with that. So there are like a bunch of devices that sends and receive network, and you should figure out which device is actually responsible for that. So this is example of like incoming and outgoing network um, coming from this device, which is NO1. It probably stands for one of the hardware devices within the node, and you just gotta figure out what is that exactly. So far, like I have, yeah, different devices sending and receiving networks. So that's it. These like the tools that I'm using to help me monitor the situation and hopefully like diagnose bugs.